For this problem, a force of 500 Newton is directed from A to B in the cube shown below. We are tasked to compute the moment about the x-axis in Newton meter, the moment about the y-axis in Newton meter, and the moment about the z-axis in Newton meter. Now to solve this, we first have to plot the coordinates of the head and tail of the force vector. For point A, that is a coordinate of 0 along the x-axis, a coordinate of 4 meters along the y-axis, and a coordinate of 4 meters along the z-axis. And for point B, it has a coordinate of 4 meters along the x-axis, a coordinate of 1 meter along the y-axis, and a coordinate of 0 along the z-axis. So we have the coordinates for A and B. We can solve for the components of the length of the vector, Lx, Ly, and Lz. So to solve this, going from head to tail, we subtract the x-coordinate to get the length along the x-axis. That is 4 minus 0 equal to 4 meters. And for Ly, that is 1 minus 4 equal to 3 meters. We can disregard the negative sign because we're dealing with units of length. And then we have Lz equal to 0 minus 4, that is negative 4, or basically 4 meters. Now we can solve for the overall length by taking the square root of the sum of the squares of the components, that is L squared plus Ly squared plus Lz squared, and taking the square root. So we have L equal to square root of 4 meters squared plus 3 meters squared and 4 meters squared. Solving, we get L that is equal to square root of 4 squared plus 3 squared plus 4 squared, that is equal to square root of 41, or approximately equal to 6.40 meters. Now that we have L, we can also solve the forces into its individual components along the x, y, and z axis. So we have a component along the x-axis, let's call this fx, a component along the y-axis, let's call this fy, and a component along the z-axis, let's call this fz. Now to solve this, we make use of ratio and proportion of the forces to the lengths of the force vector. So we have the ratio of the component along the x-axis of the force to the overall net force equal to the component of the length along the x-axis divided by the overall length. So you have Fx equal to force times Lx divided by L. Doing the same to the other components, we can solve for Fy and Fz. That is equal to force times the component divided by the length. So Fx is basically equal to F that has a value of 500 newtons times the component along the x-axis for the length, that's equal to 4 meters divided by the overall length, that is 6.4. And doing the same to the other components, we have 500 times Ly divided by L, and for Fz we have 500 newtons times Lz, that is 4 meters divided by L, 6.40. So we have Fx equal to 500 times 4 divided by 6.4 equal to 312.5 newtons. And for Fy, that is equal to 234.375. And Fc, that is equal to 312.5 newtons. Now that we have our components acting along the x, y, and z axis, we can also solve for the moment of the force about the coordinate axis. Now starting with the moment about the x-axis, notice that only Fz and Fy could induce a rotation about the x-axis. And considering counterclockwise to be positive, we have moment about the x-axis equal to negative Fz, since it is clockwise, times the moment arm distance of 4 meters plus the force Fy that induces a counterclockwise rotation multiplied by the moment arm distance of 4 meters. We have moment about x equal to negative Fz, that has a value of 312.5 times moment arm distance of 4 meters plus Fy, that has a value of 234.375 kilonewton times moment arm distance of 4 meters. We have moment about x equal to negative 312.5, or approximately equal to 312. And the negative sign here indicates that the moment is acting in the clockwise direction. So now that we have solved mx equal to 312.5 kilonewton meter going clockwise, we can now proceed solving for the other remaining moments. So for my, moment about the y-axis, considering counterclockwise to be positive, we have only the x component of the force could induce a moment about the y-axis, so we have Fx times the moment arm distance of 4 meters. So we have my is equal to Fx with a value of 312.5 kilonewton times 4 meters equal to 1250 kilonewton meter. That is letter B. And to solve for the moment, acting about the z-axis, notice that only Fx could induce a rotation about the z-axis. So let's consider that counterclockwise to be positive. We have negative Fx that induces a clockwise moment times the moment arm distance of 4 meters. You can solve for mg. It is equal to 1250 kilonewton meter, and it is negative, which means that it acts in the clockwise sense. And that is letter D.